if you remember in the previous lab, we discussed linear regression. So where we have written our own code. After that, we used linear regression and we used the Python library. And then we discussed a multi-linear regression. Multiple linear regression means whenever we are using more than one feature. Do you remember all these things? Linear regression, writing your own code, linear regression using the Python library, linear regression but multiple features, that is more than one feature. So all of we discussed in the previous lab. So we are further continuing. So I will give you the one more example for multilinear regression. Then we will discuss the classification, the next topic. Clear? And I will show you some more things in the multilinear regression. So the Python libraries are the same that we discussed in the previous lab, but one more library will be required here for the classification. So I will discuss whenever we will come to the second question. So the first question here is the related to the multiple linear regression. See, so the question is we are having the same data, but this time we are just playing around with the data. So first thing is we are going to display the pairwise correlation of all the attributes. Why it is required? Anyone can tell? Display the pairwise correlation of all the attributes. See, in the housing data, just yeah, okay, so this is your house data. And we do not know which feature or which attributes depend how much on other feature. We are not familiar with this thing. Okay, so we will display the pairwise correlation coefficient, so we can justify, okay, these two features may be correlated or these features are important for our linear regression. Yes or no? Because in the lecture we also discussed how to eliminate irrelevant features. Okay. So this time we will see how we will see the correlation coefficients between the different features, and then we will select some of them. So the first is clear why I am talking about this. Display
Yes.
the pairwise correlation coefficient of all the attributes. So for this, we just need to use this .cor. Okay. I will show you the documentation if you want to see. It is used to find the pairwise correlation of all the columns in the data frame. That means our house data. So we have read our house data using pandas data frame. Okay. Pandas data frame. Yeah. So now in the pandas data frame, we will use the data frame name. After that .corr. Okay, module. So it will find the pairwise correlation of all the columns. So we are having 13 column. So we will have 13 by 13 matrix. We will have a 13 by 13 matrix. Okay. And any NA values not applicable. That means any NA values will automatically excluded. For any non-numeric data, type column in the data frame is ignored. So if you are having any non-numeric data, it will be ignored. If you are having any NA values, that will automatically excluded. Clear? So first we will see the correlation. Okay, correlation. After that, what we will do, we will just visualizing the data this time. मतलब कि which features are correlated and which are not, so that we can extract some important features out of the all the available attributes of features. Clear? So next, what we are doing, we display the heat map of the correlation matrix. the correlation matrix that we obtained in the first question, we will display the heat map. Heat map क्या है? Is defined as a graphical representation of the data. So the matrix that you obtained in the first part, you are just graphically representing them using colors. Using colors. ठीक है, in this to represent more common values or higher activities, brighter color. So using this graphical representation, you can see which features are they have actually different color for different coefficients. So using this, we can see darker color have something other importance, brighter have something other. So we will see this. Okay. So for heat map, see all the whenever you will deal with the large data set, you may encounter out these things that I am discussing. Correlation coefficients you need to find. Using the heat map, you need to justify how they are correlating graphically. You can see. So import C1 as SNS. Import C1 as SNS, and after that this heat map module we need to use. Okay, and the matrix be obtained here. Yeah. So I will show you these two things here. These two things clear? What is the purpose of this?
Yes, sir.
Yeah. So coming to our course program. Okay. So first things we start with the libraries or packages. So import numpy as np. We already discussed numpy package. Import pandas as pd to deal with our data set, and matplot for plotting purpose. These three libraries. So we have just imported these three libraries, and first task is to read our data set, house data.csv. Okay. In the previous question we did the same things, but randomly we have selected one features and we just did our regression. Okay. We didn't take care about which features is good, which feature is not good. So in this question we will see that. Okay. So yes, see, this is our data set here. Okay. This is our data set. I am just displaying the top 5 rows. Okay. Now what I will do, these columns. Okay. So there are around 21 columns are there. Okay. So we will find the correlation matrix. Correlation matrix. Okay. So so this will be a 21 by 21 matrix. 21 by 21 मैट्रिक्स. आपको याद होगा हमने we used variance and correlation in the linear regression. Do you remember?
Yes, sir.
है ना. इस बार क्या होगा, we will find the correlation between id and id, correlation between id and date, correlation between id and price, correlation between id and bedroom, and so on. Then correlation between date and id, correlation between date and date, correlation between date and price, and so on. अगर वो वैल्यू 1 है, दैट मीन्स दे आर हाईली कोरिलेटेड. अदरवाइज लोअर वैल्यू है तो दे आर लेस कोरिलेटेड. ठीक है. सो सी this is the data set. क्या, this is our data set. See, our data set is a pandas pandas data frame pd. So you can see here the methods available if you want to see. Data set dot, yeah, you can apply all these modules. You can see. So I am using what? COR. This one, you can see this one. Just question mark and read about this. Yeah, compute pairwise correlation of coefficients excluding NA values, null values, not numeric values. It will exclude all the things. Okay. So this is already available in pandas PD. Okay. Pandas, it is already available in this. Okay. So this is just a data set dot CORR. I'm just printing this. Clear? Now you can see this is our matrix. What is the size here? It is 21 by 21. We can print their shape as well. Oh, don't know whether this is available or not. Yes, shape is available. Yeah, it is 20 by 20. I think ये वाला drop हो गया होगा maybe. ठीक है. So see, या कोई non numeric value होगी, then that is dropped. I think the non numeric maybe. Okay, so see, yeah. So ID versus ID. ठीक है. Then ID versus price, then ID versus this. ठीक है. तो इसको अगर हम नेक्स्ट उस पे कर देना, जस्ट मिनट, थोड़ा अच्छा लगेगा. हाँ देख, सो यू कैन सी, एक्चुअली वो भी ऐसा फील हो रहा है कि नो. Yeah, now you can see it is just like a matrix. ठीक है. So ID versus ID 1, obviously, because both are same. ठीक है. And they are inversely correlated, that means -1. ठीक है. So you can see the all the diagonals value must be 1. All the diagonal values must be 1, because bathroom versus bathroom correlated. ठीक है. Floor versus floor correlated. That's why these values are 1. ठीक है. So using this you can see which one is highly correlated and which one is not so much correlated. ठीक है. So you can see this is square feet lot 15, square feet lot 15 and square feet lot. These are you can say these are correlated somewhat. 70% they are correlated. Yes or no?
Yes, sir.
है ना. So this is the purpose of the finding this correlation matrix. ठीक है. Okay, this one. So this is all matrix. Okay. Now see, reading this whole matrix is a quite difficult. Reading this whole matrix is a quite difficult. So instead of using this matrix, what we can do, we can plot the heat map of this matrix. Heat map. Okay. So import C1 as SNS and SNS dot heat map. Okay. So it will just display the graphics of this with the different colors. Okay. So the one that means if they are highly correlated, it is a brighter color. They are brighter color. So you can see ID and this ID, this brightest color. Price versus price. My cursor is visible. This price and this price. Okay. So all the diagonal values are brightest. Okay. And see one more we can see ID versus price. You can see ID, this is ID and this is price. You can see this price, price 1, ID versus price, it is minus. It is just around 0, I think. So they are not correlated. It is around 0. So it is the darkest color. Is it fine?
Yes, sir.
So this is the heat map. So you can see which one, if you're reading this is too difficult, then we can use the heat map and we can see these are highly correlated and darker color are less correlated. So okay. Now what we are choosing here, we are choosing a square feet living and bathroom. Okay, see square feet living is this one and bathrooms is this one. Square feet and bathroom. So we are using, you can see my cursor is visible. We are using bathroom and square feet. So we are using this feature. In the previous one, we used only one feature. In the previous lab, we used only one feature. So we have selected 5 features right now. Square feet living, bathrooms, grade, and I think we used 4 features and square feet above. We used these 4 features. Clear? So next question क्या था in the yeah. So these 2 things are clear. What is the purpose of heat map? Now next. Now next what we are doing, we are using 4 features to train our data set. So we are using these 4 features. Okay? And using these 4 features, we will train our data set, and obviously the price will be the y value. We will train our data set. We will split our data set into training and testing. Then we will perform the model fitting. Then we will check the accuracy. Okay, so the first question is clear of today's lab.
Yes, sir.
And there were 2 things were new, and the other things were from the previous question. So I'm discussing the solution as well. Clear? Clear. So this is our features that we are going to use. That means the column. So this is our x values. You can say x matrix. Clear this one? This is our data set, and in this data set we are just selecting 4 columns. Which columns? We are selecting these 4 columns. Clear? So we are selecting these 4 columns. Okay, do you want to print this?
Yes, sir.
We will print this and we will see. Okay, price. Okay, so once we print this, we have this type of printing. Okay. So, but for our machine learning, we need our data in which form? We need our data in the form of the matrix. Yes. So what we can do, we can use this np.array space and this. Now you can see this will be our x values and this will be our y values. Now see, this is our x, that means matrix x, and this is our y. Clear this one? Why we used this np.array? Because initially our data is not in the form of the matrix, because it is a data frame. It is a pandas data frame. Clear? So we used numpy.array and this data set. So now we have our data in the form of the matrix. This one is clear?
Yes, sir.
Okay. Okay, this one is clear. Okay, so now till now we have just generated our data in the form of the matrix which is required for our machine learning model. Clear? Now next task is in the machine learning. The next task is always the training test split. Splitting the above data into training and testing. Okay. So I'm discussing the solution as well क्योंकि अभी you all are new. ठीक है, but I will not share this file. So you need to write your own code whenever you submit the solution. ठीक है. So from sklearn dot model selection import train test splits. You will find this package all the time in your data science and machine learning classes and labs. ठीक है. So from sklearn dot model selection train test split. Train test split x y test size is 0.2. That means 80% data is the training data and 20% data is the testing data. Okay. In the next lab, I will show you something other more than this. So you can find the accuracy for different test cases, just like first 20% for randomized, then again for 20%, then again for 20%, and so on. Yes or
Uh,
no? Are you
sir,
getting my point? What I am saying?
hello, sir.
Ah, yes.
Sir, if you have to split this data in 70-30%, then the value of test size will be 0.3, right?
Yes, just 3 here. You can
Okay.
see. Okay. So just I now you can see it is 70-30. देखना पूरा साइज क्या था 21613 21613. तो it is 70% and it is 30%. ठीक है. So this is our training data. X train, Y train, X test, Y test, train test, train test. ठीक है. Clear? This one is clear?
Yes, sir.
Yeah. Now we will use this X train and this X train and Y train, and we will fit our model. If you remember, what our goal here is, our goal was the y equals to mx plus c, but here we are having 4x, 4 features. So m1 x1, m2 x2, m3 x3 plus m4 x4 plus c. Our goal is this. Linear regression, that means we assume that uh, sorry, this I need to write here. So as we assume that our data is linearly dependent, that means price is linearly dependent on these 4 features x1, x2, x3 and x4. Okay. So using this regression dot fit, we are just going to find m1, m2, m3, m4 and c. Okay. Find fit the model and find the parameters. Okay, that's it. That means the model name. Here you can write any name. Okay. In the previous lab, I think I have written model model. So just fit this model. Okay, now our model is ready. Our model is ready. If you want to see, we can see here reg regressor dot intercept run. So this you can see the C values and regressor dot coefficient, I think. Yes, coefficient. This will be your 4 m values, m1, m2, m3, m4. This. This is clear what I am talking about.
Yes, sir.
You know? So that means y equals to this into first feature, that means x1 plus this into second feature plus this into third feature plus this into fourth feature plus this intercept. That's it. Okay. Now what we are going here, just recall from the lecture, we are just going to find this by predicted. If you remember, m1 x1 for testing data, I can write here x dash, confusion you now. Unknown data, we are just using this m2 x dash 2. Okay. m3 x dash 3 and m4 x dash 4 plus c, and we are just going to find this y value. Okay. And we will compare this y value, that means a predicted y value, with the y value that we already have, this y value for the testing data, and we will see how much they are closer. Clear?
Yes, sir.
Because we used this training data only. Now we want to see the parameters that we have calculated is good for our unknown data or not. Okay. So we are just going to find this. Okay. So by predicted value for testing data. See. Yeah. And this is our predicted value for testing data, and this is was the our original value by test for the original value, and this is our predicted value, and we are just calculating the accuracy. So our model is giving around 54% accuracy. just only 54% accuracy. This is clear?
Sir, I have one doubt.
Yes.
How can we improve this accuracy?
Yeah, that is. Uh, Either you need to change the features, or there may be the case that your model is not the linear regression is not suitable for your data. So instead of linear, you may use a polynomial regression.
Okay, sir. And sir, how much accuracy should a good model have?
It depends on if you read this research paper for different kinds of data set. Some research paper will show you 95% accuracy. Then in the coming year, maybe some other have some better approach for this. How much accuracy is always a question mark. Initially, you do not know how much accurate it should be. Okay, it is always a research topic. So for some cases you can say 90% accuracy is good. For some case you can say 95%. We need at least 95% accuracy. So if I will show you a research paper of one of my friend, so for mammogram classification he obtained around 99% accuracy. But we can't say that this model will give you 99% accuracy for other data set. Are you getting my point?
Yes, sir.
You know, for this data set, suppose in this data set, instead of linear regression, you just apply some other thing and you may have better accuracy, or you some apply some pre-processing. यही तो research है. You just apply some pre-processing and see how you can have a good or better accuracy. ठीक है. So this is something you can say the question mark. It depends on the data. Which data is this and how much accuracy it require. So if 90% accuracy is available, then your goal is to have better accuracy. So just try to improve this and just propose your work. And now for this model, for this data set, I have a better model which is having better accuracy than the existing work. Clear?
Yes, sir.
Okay, I'm just adding one more feature. अभी हमने कौन कौन से feature लिए हैं? We have taken these 4 features: bathroom grade, square feet above. Okay, so we have taken these features. Just a minute. Okay, we can add square feet above. We have already taken square feet living. We have already taken square feet lot. We can take grades is required or not? There is grade. Yeah. I do not know. One more thing is that if you normalize this data, you may have better accuracy. If you normalize. Okay, so we will see. I will give you the example where we will normalize our data. So I'm just trying to add one more feature. Is square feet build. Great. No. Okay, I think ये वाला और ऐड करते हैं square feet lot. Okay, square feet lot ऐड करते हैं. एंड स्क्वायर फीट बेसमेंट भी ऐड करते हैं. Okay, so now we are trying to use these features and we'll see whether we have good better accuracy or not. ठीक है, तो स्क्वायर फीट लिविंग, ठीक है, and bathroom we are already using grades, square feet above, square feet lot and basement. ठीक है, फिर से ही करते हैं. तो we need to start from here. Yeah, just here. Just run it. Okay, कहाँ गया? Yeah, now run it. Run. Okay. Now you may have 6 coefficients here. Yeah, you can see 6 coefficients are there. ठीक है. Now apply this. अभी भी 54% एक्यूरेसी है, so there is no improvement till now. ठीक है, so you need to
मतलब
try.
जो सर जो ट्रेन के लिए जो हमने मॉडल लिया, डेटा लिया, अगर उसको ज़्यादा बढ़ा दे, लाइक उसका परसेंटेज ज़्यादा बढ़ा दे, तो एक्यूरेसी पे अफेक्ट पड़ता है उसमें?
Now see, if you are increasing the training size, ठीक है, तो there is a no fixed rule के how much data should be training and how much it should be testing. Generally what we did, we will try to take 10% gap. Maybe you can have a 50-50, then 60-40, then 70-30, and then you can test. So in the next class I will go over the cross validation. There is a one Python library, and using that library you can repeatedly apply your model. मतलब कि you will divide your data set into 5 or 10 fold, and in each fold you will build your model. ठीक है, and then after that you will calculate the average of the accuracy. This time what we are doing, we are just using one split. ठीक है, but it is not a good practice to split your data set one time. So we repeatedly split our data set 10 times or 5 times or 20 times and obtain the accuracy, and then we need to do the average. ठीक है, so if you wish we can try to play around with this, but there is a no fixed quotient actually for this.
ओके सर।
है ना, अभी देखो या 55% एक्यूरेसी है ऑन द टेस्टिंग डेटा. Got it? So as you suggested, we just changed this and now we are having 55% accuracy. So we need to just play around with the data. Data को clean करो, transform करो, and extract relevant features. Extract relevant features out of these 21 columns. So you need to find which columns are more appropriate. Or instead of linear regression, whether there may be the case of polynomial regression. ठीक है, clear?
यस सर।
ओके, मैं सोच रहा था कि कुछ एक प्ले अराउंड करके देख लें, मे बी कोई बेटर फीचर मिल जाता. स्क्वायर फिट लॉट 15, स्क्वायर फिट लिविंग, ये दो फीचर और ट्राई करके देखते हैं. लेट अस सी व्हाट हैपन देन. ओके, फीचर्स हमने पहले आई थिंक नहीं लिए हैं. ओके, सो स्क्वायर फिट लिविंग 15, वन मोर फीचर, एंड स्क्वायर फिट लॉट 50, है ना. सो वी आर ट्राइंग 8 8. नो, अभी भी कोई इम्प्रूवमेंट नहीं है. सो वी नीड टू चेक, मतलब अब कैसे इम्प्रूव करेंगे इसको. दिस इज अ टॉपिक फॉर यू कैन से योर प्ले अराउंड. ठीक है, 54% है. ठीक है, सो यू कैन ट्राई अब. ठीक है, you just change from linear to polynomial. In the next we will discuss regress, मतलब normalization. So you can check, you can normalize your data and then check whether it is good or not. ठीक है, this one is clear,
यस सर।
है ना. Okay, so you need to write your own code and just check. Now next is the very important things, and most of the time you will find this. Okay, support vector machine. Anyone familiar with this? What is support vector machine? Any one of you?
नो सर।
Okay, see. Okay, so I will in this I can add it actually. That's why I'm starting. Okay. Actually, I can go over the mathematics of the support vector itself. I have taken a one tutorial and lab in IT Indore, but it is not in your syllabus. This, see, I have the mathematics here for the support vector machine, but I'm not sure whether you will understand or not. So instead of going to the mathematics, I will tell you why it is required. ठीक है, see. Okay, so why we are suppose now you are having your data. You are having your data. Suppose this is your data. Now you are having this data. Okay. What is the purpose of support vector machine? We are using just here for linearly separable data. Linearly separable, what does it means? We are assuming that our data is linearly separable, but it can be used where data is not linearly separable. Keep in mind, this time we are just using for linearly separable data, but there may be the case that your data is not linearly separable. So we will have a support vector machine for non-linear separable data also. So what support vector machine will do? It will find a something like this, a window like this. Okay? And in this window you will have your data points like this. Okay, so if you see the mathematics here, if you see here, यहाँ पे आपने देखा होगा कि what is the goal here of support vector machine? The goal of the support vector machine is to find this, and our goal is to have all the data points in between these two parallel lines. Our goal is to have all the data points in these two parallel lines. Okay, so this is called gap. Actually, this is called gap. So suppose this graph is visible to you.
Yes, sir.
So similarly, suppose we are having our graph here, and suppose this is a line. You can say, what is the equation of line? Y equals to mx plus c, or we can write a0 x0, and instead of x, yeah, a0 b0 y0 plus c equals to 0. We can write this just similar to y equals to mx plus c. Yes or no? This is an alternate form. Everyone familiar with this? Hello? At least say yes or no. Am I audible?
Yes, sir. Yes, sir.
है ना? See, y equals to mx plus c is a equation of line. I am just writing in this form ax plus by plus c. एक दूसरी line है. In this line, instead of a0, you are having a1 plus c is equals to. ठीक है? And our goal is to find this is the distance between these two lines. So if you, I do not know whether you remember or not, in the mathematics we can find the distance between two parallel line. So these two lines are the parallel line. Okay, so we can find the distance between these two parallel lines. So we can find this distance. Okay, and our goal is to what our goal is to? Our goal is to find this 1/2 W transpose W. It will not clear. आपको इससे समझ में नहीं आएगा. Okay, stick to here. ठीक है. So suppose our data is linearly separable. Okay, so what support vector machine do? It always try to find some plane. You can say it will always try to find some plane, and will always try to fit all your data, your training data in this plane. You can see this reason that I am moving my cursor. ठीक है?
Yes, sir.
है ना? So it is just, you can say कि we are using this for the classification purpose. We are using this for classification purpose, and there are many parameters available. So where you, instead of using linear, you can use for non-linear separable data as well. और कई सारे parameters हैं, you can change that parameters, and you can increase the width of this hyperplane. There are many things, but we can't go in the mathematics, so I will show you the programmatically how it works. The concept of support vector machine is clear. We are using this support vector machine for classification. We are using this support vector machine for classification. Classification means we just need to classify whether it is cancerous, non-cancerous image, spam or not spam, or anything else. Clear है?
Yes, sir.
ठीक है. I think last time I have shown you a research paper where the authors also used as support vector machine. Do you want to see that, or we can continue our lab? In the research paper, if you just Google, you will find support vector machine, SU support vector machine for cancer. For किसके लिए? Mammogram classification. You will find the many research paper. देखो, support vector machine for mammogram classification, support vector machine for किसके लिए? For image classification, for text classification, for heart disease prediction, for fake news detection. So it has a wide applicability in the domain of machine learning and data science. Yes or no?
Yes, sir.
है ना? So our next question is related to the classification. Okay. So we are using an database that is available in the sklearn.dataset sample generator. Okay. So first I will show you this data set, then we will visualize this data set. And then I will show you the working of the support vector machine. Okay. So see, coming to here. Okay, this is done. Now the next was the SBM. And keep in mind, I'm giving you the example for linearly separable data. Okay. Support vector machine can be used for non-linearly separable data itself. Okay, so this is the file C. NumPy as NP. This is for plotting purpose. Okay, this is for scientific computing. SciPy we have already discussed. Now see. First thing is we are just taking some data set. Okay, from sklearn data set. Do you want to see this? See the Python documentation. Toy data set. No, sorry. Sklearn data set, and this is having a lot of data set actually. So, and one of them we are using. You can see this Boston house price data set we used in our last lab. Breast cancer data set. Okay, so it has a lot of data sets available already, sklearn Python library. So we are using this data set, make blobs. Clear?
Yes, sir.
Okay, so we are using this data set. If you want to see this individual data set, we can write here and you can see this. See, generate isotropic Gaussian blob for clustering. Okay, so we are using this data set, and in this data set, how many samples we are taking? We are taking just 50 samples. We are taking 50 samples, and we are taking center is equals to 2. What does it means? What does it means? Okay, just a minute. Chalo, we have started from here, and I will show you this. Okay, see. I have taken 50 samples. So you can see there are 50 samples. If you count these circles, small circles, these are 50 in number. Okay. Center is equals to 2. That means we are just assuming that there are two categories of data. So one might be in the falling in this category, and one might be following in this category. If I just change from 2 to 3, You can see. Now it is visible to you.
Yes, sir.
है ना? So just means this time we are using some dummy data, just like if you are using a mammogram classification. So your data is having two kind of mammograms, whether they are cancerous or non-cancerous. So you can say the cluster is 2, or you can say the class is 2. Okay. If you are working on the handwritten digits classification, so digits are from 0 to 9. So there are 10 classes are there. Okay. So here I am showing only the two centers, two. Okay. These are the other parameters, so you can learn about them कि क्या होते हैं ये. Make blob question mark and you can see. Okay, कहाँ गया? Sorry, इसको अलग से run. We need to run it. Okay, just a minute. You just write this and see what are other parameters are there. Okay, so number of samples by default they are 100. We have taken only 50. And number of features by default is 2. Okay. Okay, so you can see the random state, shuffle center, centroid cluster, centroid default value is 1, we can set. So these are the other parameters which are optional as well. Okay, you just need this. So it will return x values and it will return y values. What x and y values? Just like in our previous example, x means your training data features and y are their price in the house price data. Okay. So you can see, so this is your it will return x and y are the classes and x are the samples. Okay. So if you plot this, if you want to see this, these are the 50 entries. You can see these are the 50 entries and these are the y values. Okay. So some of them falling in one class that is having value 1, and some of them falling in the second class that is having value 0. Okay. If I just change from 2 to 3, then what will happen? You can see here what will happen. Uh, See this one. It will have 3 classes. Can you see this? 0, 1, 2. Yes or no?
Yes, sir.
है ना? So these are just the classes. There are 3 classes. There are 3 classes. First class is having all the 0, second means 1, and third means 2. Okay. So these are just the classes here. It will return x values and y values. So instead of using this data set, you can work on your own data set. Okay. Yeah. Now the next question is in the support vector machine. We will just draw these 3 lines and see how much difference are there. Okay. So we will draw 3 lines. Okay, that approximate or separate this data set. Approximately we are just drawing. Okay. So our goal is something like मतलब one line must be in between. एक line यहाँ पर हो जाए, एक line यहाँ पे. See देखते हैं क्या होता है. Okay. So we are just drawing 3 lines approximately. Okay. So see linear discriminant analysis, we can draw them. Yeah. So see this we are just visualizing our data. X values we are visualizing, X values, and in the last lab if you remember we are using C equals to Y. What does it means? In the last lab we discussed C stand for color. Okay. Color, it is an array. Okay. So if the value, so y is an array here, so we are just passing this as a color. Okay. So if it is a 0, it will have a common color. For 1, it will have a separate common color, and for there are 2 values only, so you have only 2 colors in your graph. Do you remember? अगर आप यहाँ से इसको remove कर देते हैं, then you will have all the data points in the same color. Yes or no?
Yes, sir.
है ना? So I just keep this. see, so we are just plotting all these points. ठीक है, एक हमने just a text plot किया x, ठीक है, ओके, रेड कलर है, doesn't matter, एक x fit एक line है, so this is a line here x fit, and I'm just plotting these lines. So we just see here we are just assuming m is 1, b is this, what I'm just doing here, y is equals to mx plus ठीक है, so this is you can say mx plus c, yes or no,
Yes, sir.
है ना, mx plus b or you can say mx plus c, and x we have taken this value or m we have taken this value. So one first time I am using slope 1, slope this different value of b, and we are just plotting this line, ठीक है, so we are plotting this x value and this is y value, ठीक है, clear है, this is you can say this y value here, we are just plotting this one y equals to mx plus c, ठीक है, और दिस इज k स्टैंड फॉर ब्लैक कलर एंड डेस स्टैंड फॉर द लाइन का स्टाइल, ठीक है, सो यू आर हैविंग दिस लाइन, ठीक है, और यू आर हैविंग दिस लाइन और दिस, ठीक है, सो यू आर हैविंग 3 लाइंस फॉर फर्स्ट वैल्यू, फॉर सेकंड एंड फॉर थर्ड, सो यू आर हैविंग 3 लाइंस, क्लियर,
Yes, sir.
है ना, सो वी हैव जस्ट प्लॉट दीज 3 लाइंस, सो क्वेश्चन यही था कि जस्ट ड्रॉ 3 लाइंस that approximately separate this data. So you can see above this line the data fall in one category, below this line the data fall in another category, yes or no,
Yes, sir.
just like हमारा ये था ना, just like ये एक line है, ठीक है, so suppose there are some data points, यहाँ पे data points हैं, यहाँ पे data points हैं, so all the data points in one class, all the data points in another class, and this is you can say the decision boundary, this is called decision boundary, and these are the bits, ठीक है, कुछ data points होंगे that may be here, so if these are above this line, so this may be in this class, below this line this may be in this class, ठीक है, so अभी तक हम so till now what we were doing, we were using linear regression, so we were just finding a line, ठीक है, of this time we instead of this line we are finding 2 parallel lines, that is the width here, and the data on the one side of this line may be in the one class, data on the other side of this line will be in the second class, clear hai? Yes or no?
Yes. Yes, sir.
But see, in the example we just manually did this, we just manually did that, but actually the SVM the this is the task of the support vector machine, this is the task of the support vector machine. I'm just trying to show you okay, how in this manner support vector machine works. So the support vector machine will try to find these lines, support vector machine will try to find these lines, ठीक है, एक और example, suppose what I told you, just let me check, okay, I have given only 2. Now suppose data is not linearly separable, data is not linearly separable, then I need to upload this edited file or the original file in the LMS.
Sir,
Let data is not linearly separable. Data is not linearly separable. So suppose instead of this line, your SVM may have this kind of shape. Your SVM may give this kind of shape. So the data points above this may be in the class 1 or class 2. Yes or no? So this is called non-linearly separable data. non-linearly separable data. So for this kind of SVM, Python libraries are also there. ठीक है, clear my point?
Yes, sir.
है ना? See, mathematics is very interesting in case of data science or in case of machine learning. ठीक है, but क्या है कि if we start going into the mathematics, पता नहीं how much time it will take, whether you are able to finish the syllabus or not. So that's why I am just following the syllabus जैसे कि आपके syllabus में है. ठीक है, otherwise I am very interested to show the mathematics actually. ठीक है, so I have shown you this. ठीक है, just take a 2-minute break and just ask your doubts till now. Any question till now?
No, sir.
है ना? It is clear why we are learning support vector machine.
Yes.
It is widely used in classification. I have shown you the Google where I have written only support vector machine for. After writing for it, it was showing many different examples for digits classification, for mammogram classification, for image classification. There are a lot of examples. So it is for classification, first thing. Second thing is it is a very accurate, it gives you very accurate results in terms of accuracy. Okay, there are a lot of models are there, but support vector machine is one of the best one. Okay, it is also used for non-linearly separable data. Okay, we are working on the linearly separable data, but you can work on non-linearly separable data itself. Okay, other than this, there are many things you can play around with this, and you can change the working of this model. ठीक है, there are many parameters, so you can play around with them. ठीक है, एक soft margin होता है, but we can't go here अभी. So till now this is clear.
Yes, sir.
ठीक है, okay. अभी तो बहुत बड़ा है. I will show you each and everything. अभी मैं I am just trying to build the base. Okay, so I am trying to build the base here. Okay, so I have shown you these things. ठीक है, ये line थी हमारी xfit. This was the line. Okay, so this line we have already plotted. This is the x value. Okay, again. Okay, now this time I am again plotting the same line. I'm again plotting the same line. You can see the same line, but this time I am just giving some thickness of this line. जो thickness का purpose क्या होता है? You can say I am giving some margin. ठीक है? So if the data coming in that margin, so you can say in this class. So instead of this line for 0 width, I'm taking some kind of thickness. Okay. So the same thing, we have just plotted our data scatter plot, and this time we are using this thickness, one more parameter. Okay. This is y equals to mx plus c, or you can say y equals to mx plus b. I'm just plotting this line x and y, and after plotting this line I'm just filling this gap, fill between. ठीक है, x fit, y fit, minus d say plus d. So that means I am just trying to use some thickness for this line. This one is clear?
Yes, sir.
है ना? So all the things are same. We just have this one more parameter that is called the thickness. Say the thickness. ठीक है, thickness d, thickness d. ठीक है, so minus d2 plus d. ठीक है, so this you can say this is your line y equals to mx plus b, and this is minus d. From minus d to plus d, I am just filling this space. Okay, so I am just using some kind of you can say the margin. We are using some margin, and we assume that if data points fall in this margin, so we can justify whatever we want to do. Okay, so we are using some kind of margin here. The same thing. This is clear?
Yes, sir.
ठीक है, अभी तक जस्ट we have not worked on the support vector machine. I am just showing you the what support vector machine can do. ठीक है, we are just approximately plotting these lines because we have already visualized this data, so we are just approximately plotting, but real life में data you do not know. ठीक है, now say a support vector machine, just read. ठीक है, support vector machine offer one way to improve on this institute is rather simply drawing a 0 bits line between the classes. We can draw around each line a margin, वही same है. Instead of the 0 bit we can draw some margin up to the nearest point. ठीक है, maximizing this margin. So the goal of the support vector is to maximize this margin. ठीक है, so see, now this is your support vector machine. I will show you the here first. Check here. This one. Support vector machine are set of supervised learning method for classification, regression, and outlier detection. So we are just showing you the example for the classification here. So what is support vector machine? These are supervised or unsupervised? Hello?
Unsupervised.
Supervised. Yeah.
Oh.
We know the labels. We know the supervised में क्या होता है? We know the y values. We know the labels. So if you see the example, हमने example लिया ना, so in the example we also have the y values.
Yes, sir.
ठीक है, so I'm just showing you the one example. So from sklearn import sbm. From sklearn import sbm. मैं एक dummy data ले रहा हूँ. This is your x matrix. This is your y. ठीक है, so what does it means? Just a minute. See, your data must just like this 0 0 1 1 ये है ना. ठीक है, and y values are this 0 1. ठीक है, so this is just a small example. So in the support vector machine SVM we have this SBC, that is called support vector classifier. Support vector classifier. ठीक है, so जैसे कि हमने जस्ट लाइक वी डिड इन द लीनियर रिग्रेशन, वी यूज्ड sklearn dot model selection, after that linear regression, so just like same. ठीक है, after that this name dot fit x comma y. ठीक है, this is just the syntax है. ठीक है, so see, so from sklearn dot svm import sbc, that means import support vector classifier. Clear? Or you can write this, जैसे कि हमने in the example I have written from sklearn, ठीक है, import svm, ठीक है, and you can write this model is equals to svm dot svc. Either you can use this, ठीक है, or you directly you can use this from sklearn dot svm import svc. Clear है ना? Nothing is different. Yes or no?
Yes, sir.
है ना, alternate पे है, nothing much. ठीक है, so we have just imported svc, that is called support vector classifier. Support vector classifier and sbc bracket kernel linear. I will show you what is the purpose of all these. svc and check here. Okay, kernel is this radial basis function, degree, gamma, blah blah blah. Okay, support vector classifier. Now see what we used here. Linear. That means we are we are working for the linear classification. Clear? Yes or no?
Yes, sir.
ठीक है. These are the C values. C values, I told you there are many parameters using that you can play around. ठीक है. So this is a one more parameter, that is regularization parameter. The strength of regularization is inversely proportional to C, so must be strictly positive. So this is a positive. ठीक है. This is a positive, and using this you can vary the performance of your SV support vector machine. ठीक है. One more parameter. ठीक है. These are the kernel. That means linear for linear classification, polynomial, radial basis function, sigmoid. There are a lot of available. I think you are aware with the linear and polynomial only. But एक और है रेडियल बेसिस फंक्शन, वन मोर इज सिग्मॉइड है. ठीक है. प्री कंप्यूटेड, मतलब यू हैव ऑलरेडी कंप्यूटेड एंड देन यू वांट टू यूज दैट इन योर SVM. ठीक है. Clear? So we are using linear. We can use polynomial, we can use RBC, sigmoid, blah blah blah. Clear? By default is a RBF. By default it a RBF. RBF stand for radial basis function. एक फंक्शन है जस्ट लाइक y इक्वल्स टू mx प्लस c और y इक्वल्स टू ax स्क्वायर प्लस bx प्लस c. Radial basis function, there is a one more that is called radial basis function. Clear? So which kernel we are using?
Linear.
Yes, we are using linear. ठीक है. Depend on the data, you can use polynomial, you can use RBF, you can use sigmoid, etc. ठीक है. See, I told you this is a regularization parameters. Since we have not studied the mathematics, so it is very difficult to understand just by the definition. You just understand this is a one kind of parameters. I will try to show you here. एक parameters हैं यहाँ पे बहुत सारे actually. So using this parameter you can this let me check whether I have or not. Yeah, support vector machine for non-linear separate. Yeah, I have actually notes, but I'm not able to discuss. Just a minute. I'm trying to show you. Yeah, math. See, कुछ कई सारे parameters हैं यहाँ पे. So we can play around actually with these parameters. ठीक है. जो भी those who are interested they can contact me so I can discuss the mathematics. ठीक है. Otherwise I am skipping because it is not in your syllabus. ठीक है. So this is one kind of parameter are there and others parameters are also there and they are optional actually. ठीक है. So other parameter is the degree and degree of a polynomial kernel function. By default it is 3. So we are assuming that it is 3. ठीक है. फिर और भी parameters हैं, we are ignoring all of them. ठीक है. So you can read all these parameters. So this one is clear. We are using support vector classifier. We are using linear kernel and we are using parameter that is 10 to the power 10. Clear this one?
Yes, sir.
ठीक है. So this we used. Okay, this we already used. Now this is our model. We fit our data x comma y, we fit our data. So after fitting, अब एक और points है, support vectors होते हैं. Okay, I'm trying to show you what are support vectors. See here. Okay, support vectors नहीं यहाँ पे नहीं है. Okay. So this SVM have many attributes. ठीक है. One of them is the support vectors. तो support vectors क्या होते हैं? These are the data points on the decision boundary actually. मतलब कि suppose you are having this boundary. So these are the points on this boundary you can say. ठीक है. So these are the support vectors. This you can see the x value, this is y value. So there are three support vectors here. There are three support vectors in your case. Okay. Now we are going to plot these support vectors. We are going to plot these three support vectors. So you can see these are the three support vectors, you can say. These are the three support vectors in the SVM. Clear?
Yes, sir.
Okay. If this is clear, then you can say, now we will see the working here. Okay. So in the question क्या है हमारा? Use support vector classifier to fit SVM model on this data. Here use a linear kernel and set the C parameter very large. So beside C parameter 10 to the power I think 10 set किया था. So you can play around with this and you can use. ठीक है. Now what we are doing, we are plotting the decision boundary. This data is linearly separable, so we use linear kernel, use the concept of soft margin. That means we can use different value of C and we can see the working. So we are plotting the decision boundary next. ठीक है. Now see decision boundary कैसे करेंगे? See. Okay, so we are just writing our function here. ठीक है. अब देखो. So we are just writing our own function, plot SBC decision function. We are just passing here our model. कौन सा model है? We are just passing this model. ठीक है? We are passing this model here. This one is clear?
Yes, sir.
We are passing this model and we will use the things available in this model to plot this decision boundary. That means these three lines. Okay, we will plot these three lines. Okay, so जो support vectors हैं, these support vectors will lie on this decision boundary actually. Okay, so please see carefully. This is actually not so much required. Okay, so see, if AX is none, मतलब कि if there is nothing plotting is taken, then you can take the current access. Okay, we can avoid this actually, but for good programming purpose, we generally take care of these things. Okay, so get the current access instance on the current figure. Okay, X limit, Y limit. Okay, back if this is none, if there is nothing you are passing from in the function. I think you studied the Python programming function where you can pass variable number of arguments in the first year. Yes or no?
सर एक थोड़ा सा एक एग्जांपल देके याद आ जाए ताकि तो
देखो, I'm just giving you one example here. Okay. Actually, I taught Python this year. That's why I am asking. df function का नाम. If you are writing A, B, C here, whatever you want to do, and you are just calling this function.
यस सर नाउ आ रहे हो
2, 3, 4. So A
यस
is 2, B is 3, A 4. Now suppose I am writing this def function A, B equals to 1, C equals to 2. So you can call this function using one parameter only. By default B is 1, by default C is 2. Yes or no? Or you
यस
can use this itself. So A is 1, B is 10, or you can use this. Am I right? So B is 10 and C is 2, 20. I think you remember from the Python class.
यस सर
Okay, so that means by default AX is none. Okay, otherwise we can pass this as a parameter when we are calling this function. ठीक है. And second parameter, we are just default value is true. If we are passing something, that then it will take that value, otherwise by default it is true. ठीक है, clear. So these are nothing new. ठीक है. These are just the current x axis की limit and the y axis limit. ठीक है. So this is just a current figure axis, plt.ca current access instance. That's it. ठीक है. Now see, I'm just creating a grid. ठीक है. So np.line space x limit 0, x limit 1. What does it means? X limit 0, x limit 1, that means the minimum value and the maximum value. And I'm just taking 30 points. Just like I'm just taking this minimum value here, maximum value here, and in between them I'm just taking some 30 points. Yes or no?
Yes, sir.
These are not fixed. मतलब you can write here 100, you can write here 200. ठीक है. X value. I'm just writing a grid here. So np dot max grid y comma x. That means you are just having a grid. Okay, grid of size. Size will depend on this. अगर आपने यहाँ पे 30 लिया है, then it will be a 30 by 30. ठीक है. फिर उसको एक वेक्टर बना दिया. ठीक है. Size of this and v stack xp dot reveal y. So it will become a vector. ठीक है. Now यहाँ से from here your plotting started from here. ठीक है. So this was your model. ठीक है. In the model you are having one decision function. ठीक है. Okay, I will show you the decision function here. Just a minute. Okay, model model dot decision function. So this is your decision function here. ठीक है. Okay, question mark and see. Evaluate the decision function for the sample x. ठीक है. X क्या है? An array like, it is just an array. ठीक है. So we are just plotting the decision function. So we need to pass this value और इसको reshape कर दिया हमने किसमें? This that means grid size में. ठीक है. So this is our decision function. ठीक है. Now I'm just plot. You can see the size. The size of this must be 30 by 30. ठीक है. Now we are plotting this. So this is your x value. This is the y value here. ठीक है. So from grid, this grid size. So x value, y value. This is the decision function. I think you need to go over the contour. Contour क्या होता है actually? Okay, just a minute. Just a minute. I will show you the contour क्या होता है. Do you know what is contour? Friends, do
Sir,
you know
count.
what is?
Sir, count.
Yeah, yes, contour.
Yes, sir.
होता है?
Yes, sir.
What it is?
Sir, do you mean COUNT counter or something else?
This contour. CONTOUR
No, sir.
contour.
No, sir.
Okay, I'm just telling you. Hmm. Okay, PLT. Just a minute. AX is equals to PLT dot GCA. ठीक है. ओके, सो इसको रन करते हैं. ये तो क्लियर होगा ना आपको?
Yes, sir.
AX dot CO and yeah contour. Yeah, एक actually optimization है. In the optimization we learn actually about this. So contour क्या है? It plot the contour lines. It plot the contour lines. ठीक है. So contour will draw contour lines and fill contour. That means all the regions it will fill. ठीक है. So actually these are all used in the plotting. So we are using this contour and we are filling this space x y p. तो हमने यहाँ पे देखा था ना क्या क्या पैरामीटर्स रिक्वायर्ड फॉर दिस, सी एक्स वाई एंड जेड। ठीक है, एक्स वाई क्या है, एक्स वाई आर दी एरे लाइक, ठीक है, एंड जेड इज द एरे, ठीक है, रिटर्न कॉन्ट्योर, others parameter are not required, ठीक है। So it we are taking this x value, y value and the p values, the p values, that means the decision function, and we are just plotting a contour, we are just plotting a contour, ठीक है। So this is just a contour here. Now हम क्या कर रहे हैं, we are just plotting this support vectors, we are plotting this support vectors, these three support vectors. So if plot underscore support, ठीक है, plot underscore support यहाँ पे true है, okay, by default it is true. So if you want to plot the support vectors, then you need not need to pass anything. If you do not want to plot the support vector, you can pass here false. So अगर यहाँ पे false आएगा, then these support vectors will not be plotted, ठीक है। Now you can see, now I am running this and see here. So see, so now it is plotting these decision function, you can say this plt dot score, see इसको अभी मैं comment कर देता हूँ, now you can visualize, ठीक है, you can, this is your data here. Now in the previous one, see here we approximately plotted the 3 lines, yes or no?
Yes, sir.
We approximately plotted these 3 lines. Now this time we are using support vector machine to plot these decision function or these decision boundary, you can say, ठीक है। So I'm just looking, now I am just writing one more thing, support vector equals to false कर देते हैं इसको पहले, support vectors को false कर दिया। So you can say now this is the decision function, you can say the decision boundary, ठीक है। कैसे, we just use this is the, actually it is very difficult to remember for me itself क्योंकि कुछ points हैं are new for me and for you as well, ठीक है। So we just need to take x and y limit, some points you can take 50 by 50 or 100 by 100, 30 by 30, and you just need to create a mesh grid. So first thing is to create a mesh grid, create a grid, ठीक है। After creating the grid, our goal is to just find the decision function, because we have already evaluated our model. Just find the decision function for this xy and just plot the contour, just plot the contour, ठीक है। So contour x y p color, these are the optional things, labels, line style, alpha, these are the optional things, ठीक है। So इसमें क्या हो रहा है हमारा देखना, second one you can see, the middle one is this, ठीक है, dark मतलब a straight line. First one, these are the dash line, these are the dash lines, ठीक है। So this one is clear,
Yes, sir.
ठीक है। If I am just writing here true, by default it is true actually, so I can delete from here, okay, so by default it is true. Oh, these are the 3 ones. So you will find these 3 lines will always lie on the decision boundary. Sorry, these points, the support vectors will lie on the decision. Clear? So this is the size of x. So size of xy, that means this, this is your decision function. So this is your support vector machine. So all the points that lie on this side of this high plane will be in one class, and all the points that lie below this line will be on the another class. Clear? I think एक ही student है class में. Okay, that's clear here.
Yes sir, clear है.
Okay, so this was the your support vector machine. These are the support vectors. ठीक है, फिर हमने यहाँ पे क्या किया, बी जस्ट चेंज समथिंग और फिर उसको प्लॉट किया है. ओके, सो आई यूज्ड दिस सी वैल्यू, यहाँ पे सेम है, फिगर साइज सेम है. Okay, number of samples. Initially, we have taken 250 samples. Now I took 200 samples लिए हैं, ठीक है. And I'm just plotting 10 points here. So you can see. ठीक है. So do you want to continue? मतलब because you are alone, so I'm not sure whether you are focusing or not.
Sir, I am focusing on the.
Okay, okay, ठीक है. So till now everything is clear.
Yes sir.
Okay, now the next thing is we are just now playing around. ठीक है, कोई nothing new we are doing. ठीक है, so same thing now, same thing, model same, fit same, वही same axis, scatter plot, limit, decision function, all the things are same. Now this time I'm just playing around something. Now what I am doing, see, I'm plotting three graphs. Three graphs, sorry, two graphs. We are plotting two graphs for different samples. For different samples, ठीक है. So देखो, so see, यहाँ तक तो all these things are same from the previous. यहाँ तक I think there will be no question.
Yes sir, no question.
No question, ठीक है. Now we have created a function. I have taken a n is equals to 10. That means default value of n is 10. Otherwise, we can pass this value as a parameter in the function. ठीक है. Default value is 10 and this is your data xy. ठीक है. Okay, fine. Now I'm calling this function. See, axi comma n is in zip ax this. That means your n will be this. ठीक है. So plot SBM and AXI. So n will be what here? N will be 60.
Yes sir.
N will be 60. ठीक है. So it will go in this function. N will be 60. ठीक है. So you have taken this data set. Now from this data set, I am just taking how many points? I'm just taking 60 points. ठीक है. So now I'm just taking 60 points. All the things are same and I'm just plotting this graph. ठीक है. ये this function we have already created above. This function we have already created above. है ना. So now this time model we are passing this model. We are passing this. ठीक है. And we are plotting our model for 60 points only. For 60 points. ठीक है. So for 60 points you can see this is our graph here. ठीक है. Now for same thing, now next time we are just increasing the n is equals to 120 and we are plotting once more. So when n is equals to 120, when we are plotting, we are having this graph. So you can see when n is equals to 60, we are having three support vectors. Can you see this?
Yes sir.
And when n is equals to 120, we are having 1, 2, 3, 4 support vectors. Yes or no?
Yes sir.
है ना. So देखो यहाँ पे ये जो support vectors थे ना, we were plotting these support vectors. क्लियर है. सो फॉर n is equals to 60 there are three support vectors. जैसे हमने n को यहाँ पे 120 किया, एक और चेंज करके देखते हैं 180. अब करके देखते हैं. लेकिन अभी ग्राफ मैंने 2 ही ग्राफ लिए आई थिंक है ना, यहाँ पे 1 2 3 कर देते हैं इसको, है ना। फिर नाउ कैन यू सी दिस? अब देखो देर आर ओनली 2 सपोर्ट वेक्टर्स, दिख रहे हैं आपको?
यस सर।
फॉर 60 देर आर 3 सपोर्ट वेक्टर्स, फॉर 123 हैं, फिर यहाँ पे 2 सपोर्ट वेक्टर्स हैं। ठीक है, सो यू कैन प्ले अराउंड विद दिस, और मोर थिंग यू कैन प्ले अराउंड विद दिस सी एज वेल। इसको 2 करते हैं, इसको ओके इसको सी को प्ले अराउंड करते हैं। चलो सी इज इक्वल्स टू हमने ले लिया 1। ठीक है, now आप देखना व्हाट विल हैपन। I think it increase this decision boundary. Am I right? Just a minute, just a minute, फिर से चेक करते हैं। पहले क्या था, C is equals to E 10. You can see the decision boundary is from around 1 to 3. Now let us check. I think whenever we are decreasing C, it increasing this decision boundary. Am I right?
Yes sir, it was yes sir.
Yeah, so that parameter you can play around and you can check matlab ke you varying this parameter you may have a different classification. So this is the one parameter, and since we have not discussed the mathematics, so very difficult to say what does this parameter stand for, but this parameter will give some priority to something else. So it will just adjust this decision boundary. ठीक है, this plane you can say clear है, और you can try one more. I think इसको और बड़ा कर देते हैं, so और बड़ा करने पे it will be more closer I think. Now it is more closer. No, no, I think it is already too large. Am I right? It's already too large. No, it is not affecting too much because it is already too large. Okay, 10 करके देखते हैं, 1E1. Now it is something else. ठीक है, so you can play around with this. This is called soft margin actually. ठीक है, so this was the support vector machine. Okay, I think I have discussed here soft margin. Okay, so this one is clear. Can we continue further?
Yes sir.
Okay, I think I'm not sure whether you are aware or not. There is a one thing that is called Python's interactive visit. Do you aware with this?
No sir.
I'm also new, but I have notes. That's why I remember. Python interactive visit. What does it means? It will give you some interactive way to see all these differences. See here. देखना. So what I am doing from IPy, I can show you here. Just a minute. Just Google it, and you can have what does it means. Okay. Internet. Mm, Sorry, forget this. Oh, कहाँ गया? Just a minute. कैसे शिफ्ट हो गया? Do you know? Yeah, how to shift? Yeah, this one. Okay, what does it means from IP visit import interact with Python package adjustment? Okay, what we can do, we can use a function. So which function? This function plot SVM. Okay, and this time we are passing a list of n values in this function. So this function will take first time as a 10, then it will take this function as a 100, then 200. So see what does just what interact INTE. See, factory for instance of class instance, this class is need to support options like this interaction, this. So, so the purpose of this is that now you can have some options and you can visualize all the things at one place. See, so since I'm using the same function plot svm as we used earlier, this plot function. Okay, in this plot function what parameter we need? We need the value of n, otherwise by default it is 10. Okay, so what it will display? It will display the result of this plot SVM function with a value that is taken from this list. Okay, so now what you can do? You can just from this drop down menu and you can have the. Now I think it is clear to you.
Yes, sir.
अब मैं देखो इसमें क्या change कर रहा हूँ. I'm just writing here 500. ठीक है. I'm just writing here 500. And since I'm just writing here one more 300 400 and 499. ठीक है. Now you can see देखो. So for 10 it is giving you this. For setting 100 it will give this. For 200 this. For 300 this. For 400 this. For 500 this. सॉरी 499 करना था, आउट ऑफ रेंज हो गया. ठीक है, क्लियर है. सो आई थिंक ये क्लियर है ना. दिस एक्चुअली वी नीड टू रिमेंबर दिस लाइब्रेरी फ्रॉम IPY मतलब पाइथन्स इंटरेक्टिव विजिट. पाइथन्स इंटरेक्टिव विजिट IPY WIDGETS import interact. ठीक है, and just in the interact first parameter is the function and second parameter the value that we are going to pass in this function. So in this function we need to pass the n, so I'm just passing the list of n. Okay, so you can just set all these values here. Okay, so if you are using only 10 points, देखो यहाँ पे 10 points हैं 1 2 3 4 5 6 7 8 9 और I think color के जैसे I'm not able to see, maybe overwriting, they are overwriting. ठीक है, 100 points. So these are the 100 points, and for this 100 points this is your decision vector. ठीक है, for 200 this. So you can see मतलब कि how many data points are good for this classification. Clear?
Yes, sir.
ठीक है, you can play around मतलब कि see I have used here c equals to 10 to the power. Okay, बहुत ज़्यादा ले लिया था. ठीक है, आप क्या कर सकते हैं? You can take a c value here as well. ठीक है, you can take c value input here and you can pass that c value here and then you can use that c value here itself. Are you getting my point?
Yes, sir.
है ना कि नहीं? So it depends on you मतलब कि how much you can play around with the Python programming. So this is the support vector machine मतलब support SVM classification. ठीक है, clear?
Yes, sir.
Okay. So I will upload the questions on the LMS so you can have a look. You can see देखो मैंने I have play around with the C itself here. मैं यहाँ पे C क्या करता हूँ? Just change C 0.01 0.1. ठीक है, and देखना क्या, see how much far these are. Yes or no?
Yes, sir.
है ना, और छोटा कर देते हैं 0.1. ठीक है, so this C play a very important role in deciding this. ठीक है, so you can play around with this and I strongly advise just go over some theory part of this as well before going to the practical. थोड़ा SVM के बारे में just go over the theory part because in the syllabus it is not given. So just to go over this theory part, okay, what does is SVM, just some little idea, and then start working on it. Clear? Anything else?
No, sir.
Okay, so I'm stopping this recording. Anything you want to ask?